This offline UPS for my computer became a surplus item when I moved from desktop to laptop computer. It has been here for quite some time and battery backup had come down to just a few minutes and I was thinking of discarding it. It is rated for 230 volt 2.8 ampere 600 VA and 360 watt with battery backup and surge protection. Some time back I had bought a 180 watt monocrystalline PERC solar panel and 200 watt solar charge controller for an off-grid solar setup for ham radio. Thought of charging the UPS battery with the off-grid solar setup. Removed the 4 screws on the rear side of the UPS to have a look inside. Opened the cover cautiously and I could see a large transformer with laminated core on one side. On the other side there was a good sealed lead acid battery connected to the circuitry. Important circuitry and heat sinks were just behind the front panel mounted vertically. Flipped out the battery to see the terminals and sides of the battery to make sure that it is not visibly damaged. Red positive terminal and black negative terminal attached to the sealed lead acid battery could be slided back with some effort to disconnect the battery from the circuitry. Connected my old digital multimeter to the battery using a pair of crocodile clips. Battery voltage was seen to vary slightly between 13.36 and 13.8 volts, which appeared reasonable. Switched on the UPS and checked the output voltage. It was seen to vary all the way from 390 to 540 volts. There are two possible reasons. One, my digital multimeter is a cheap one and quite old. It is unlikely to be a true RMS meter, which is needed to measure exact AC voltage of an inverter, which is not a pure sine wave device. I have seen the same situation while measuring the output voltage of a car inverter earlier. Connected an extension cord to one of the UPS output sockets and plugged in a 70 watt pedestal fan into it. Fan worked as when connected to the main supply. Output voltage measured with my old digital multimeter came down to about 300 to 320 volts. That is better than the wild fluctuation seen earlier. Input voltage from the 180 watt solar panel kept on the terrace was around 19.65 volts as expected. This was around this value earlier when the panel was bought as well. Solar charge controller has additional output ports to connect loads in addition to the ports for connecting solar panel and the battery. Without the battery connected, the voltage to the ports were just 4 volts. Battery voltage with UPS switched on was about 12.6 volts. Connected the output from solar charge controller to the battery using a pair of crocodile clips. Charging indicator was lit up in green without blinking, indicating that charging current is not flowing. This was supported by the green color of the battery state of charge indicator on the solar charge controller. That was with the UPS switched off. When the UPS was switched on and the battery started draining, the green solar charging indicator started blinking. That means charging is occurring when needed. Solar panels were in good sunlight at that time, ready to charge the battery when needed. Thin wires connecting the crocodile clips also became quite warm. Check the voltage from the charging port using a multimeter. It ranged from 14.13 to 14.54 volts. That should be good to charge a 12 volt sealed lead acid battery from the off-grid solar setup. I had to insulate the negative terminal of the battery with a tape while trying to connect the charge controller to the positive terminal of the battery. Learned it the hard way when inadvertent shorting of the battery with the pliers produced a spark. Now the positive terminal has been connected and covered with tape to prevent inadvertent shorting. Soon after connecting the negative and positive terminals, a red triangular warning symbol appeared on the solar charge controller. Within a few moments of fixing the terminals well, the warning symbol disappeared and the green charging indicator started blinking. That was fine. As a safety precaution, I just taped the 3-pin plug of the UPS meant for connecting to main supply. The UPS was assembled back using tapes as I could not close the box properly after my alterations. I was quite happy to see the 70-watt pedestal fan running on solar energy with battery state of charge in green and solar charge indicator blinking in green color. But the happiness did not last long. After about 15 minutes or so, the fan went off and the UPS was off. Not sure whether the UPS meant for only short time backup just to shut down a desktop computer without loss of data, had auto shut off or burned off. The battery state of charge indicator was still in green and charging indicator was blinking in green. Tried restarting the UPS but I could not in spite of repeated attempts. Opened the console and the transformer was quite warm. My impression is that this UPS is not meant for giving output for a long time, though the load was just 70 watts for a 360 watt rated UPS. In my despair, I took out the battery from the UPS and connected it to my IC2730A VHF-UHF dual band radio, which I use for LEO satellite communication. The radio powered up as usual and I gave a few calls on a couple of repeaters to see if the charge will go off quickly. No, it did not, and on restarting the radio again after switching off, the usual supply voltage indication showed 14 volts. That means battery charge is full. Left it like that and came back after few hours with the radio switched off. The transformer in the UPS was now quite cool. Connected the battery back and tried to switch on the UPS. Though a beep sound was heard and transient lighting up of the indicator, nothing more than that. One more bitter lesson learned. Do not try using a computer UPS for a longer time by continuously charging the battery with off-grid solar. It is not meant for continuous usage, only for a short backup. Fortunately, there was no holy smoke, the favorite phrase of our experimenting friends.